Assalamualaikum guys, this is the last class before mid-exam. It is introduction to phase flow. So what I use is multi-phase flow in well by James Will S. Mukherjee. So we just talk about it right now as introduction before we get into the detail. So this one will be in just the introduction will be in mid-exam. Okay. So remember that we already in this class we already have the derivation of dPdL, which is from a total dPdL is a friction and elevation and accumulation. In the case, because of this one is we have a continuous flow, we end up with the thing only with the acceleration becomes 0. So we only have a friction and elevation, which is gravitational. And this one, the derivation of this, when we talk about friction, derivation of the PDL coming up here, and and then we talk about this. Okay, next is the multi-phase flow concept. Okay, in this multi-phase flow concept, we use a black oil model, which is liquid and gas. Liquid consists of oil and water, and the gas is a natural gas. So we will talk about fluid characteristic a little bit, but since this one is not fluid characteristic class, so I will just give you the equation for this one. And you have to know what is BO, BG, viscosity, mu, and Z, and etc. So in this case, we have like water, liquid water. We end up with a thing like FO. FO is water cut in this case. So we talk about it, and we will talk about this one later on. Okay. In this multi-phase flowing part, we have a water, not water, liquid and gas in this case. Okay, so let's define a parameter. The most important thing is liquid hold up, which is this notation is HL in here. So HL is a liquid hold up. Okay, and there is because of the gas is moves faster as compared to oil, so we will have a slip on it. Okay, and because of the slip we have liquid, and we have a no slip liquid hold up, which is a lambda L in this case. So and then this one is water cut. Actually is oil cut. FO is oil cut, water cut is 1 minus FO. Okay, so we have a velocity, a superficial velocity, which is a little bit different than it's not a real one. So it's a KL divided by AP. AP is the pipe diameter. And what we have is we have a velocity of gas at the actual one, but we don't what you call it, calculate that one. But there is a way to calculate the liquid. and this is the way you calculate this density and interface of a liquid gas liquid interface, okay, by using mixture, by using water cut in here. Also, if viscosity is the same thing, is using a water cut. Okay, so for okay, let stop in here for a while, and then we continue with the whiteboard. Thank you.